discussing about that concept. Okay, so I think in last class, so we have started the first data type, that is value set. Okay, so I think there are four value sets are there. So about that four value sets we have discussed. Okay, one is 0, next one is 1, and x, and about z. Okay, so whenever we have given these three values to your hardware, so what should be your output? What type of output we are getting? We have discussed it. Okay, and whenever we have supplied yes, that four values, so how that hardware should be operating, so we have discussed it. Okay, so today what we will do it, so we will move to the next second data type, that should be, we have called it as nets. Okay, so this one is also very important for whenever we are applying the what data to your hardware projects. Okay, so or otherwise hardware equipments. Okay, so here this one is a second type of data, so we are supplying to the your hardwares. Oh, here, so what is net? Okay, the net data types represent physical connection between structural entities such as gates. Okay, so before that, what I will do, so when I need to write the net as a data type. Okay, so here always whenever we are declaring net as a data type, we are using keyword as wire. Remember, whenever in your code, if wire keyword is there, then we have used the net data type. When I need to write the wire as a keyword. Okay, so here, so whenever if you have any logical diagrams, any logical diagram, physical connections is nothing but, so here we have two AND gates. How that two AND gates should be connected? So output of the first AND gate should be connected to the input of the second AND gate. So at the time, how data should be transferring? So whatever data should be there at AND one gate, that should be transferred to the input of the second AND gate. Then how I need to write so that output of the first AND gate. So at that time, we have to use wire as a keyword. Okay, whenever one gate information should be transferred to the any other gate information. At that time, how data should be transferred from one gate to the another gate? Through a wire. So because of that reason, in such things, we are using net data types. Is it clear? Is it clear where I need to use the wire as a keyword? Okay. So here, after that, net does not store a value. Remember it. Net data type does not store any values. Okay. Only so that should be transferring from one gate to the another gate. That data should not be stored in the net. Okay, there are different kinds of nets that belong to the net data types. They are wire, trie, WR. So many are there. Okay, but in your Verilog, so in whenever we have a logical diagrams, for those logical diagrams, if you are expressing in terms of Verilog code, we will use only one keyword, that should be like a wire. Whenever we have what switch level diagrams, switch level implementation is nothing but whenever your structural diagram should be implemented by using CMOS circuits, or otherwise by using PMOS and NMOS. So such diagram should be expressed in Verilog. So at that time we are using other keywords. Okay, so other keywords we will use it. Next, after that, that supply 0, supply 1, try register, try 1, try 0. These all are, we have called it as net data types. These all are the keywords. Okay, so here a wire net is typically used for nets that are driven by a single gate or continuous assignment. Okay, so the trinet type might be used where multiple drivers drive a net. So I have given one example. So here, so we have shown their AND gate. Okay, so that AND gate we have called it as G1. So that G1 AND gate is having two input. One input is B and another one is C. But only that is having one output, that I have called it as A. Okay, so because of that reason, so here in the given example, net A is connected to the output of AND gate G1. Is it clear? So that output net A will be continuously assuming. Continuously that should be changing. Whenever we apply 0, 0, so at that time we will get it different. Next, if you change the input, immediately our output should be changes. So at that time we have to use the net data type. Okay, or otherwise directly you can write it as output also, no problem. Instead of output you can write it, if you return wire, at that time we cannot store it. So when we need to use the wire, so whenever that information should be transferring to the another gate, so then only we have to use the wire. So you can normally you can check it, so in electrical connection also, for what purpose we are using the wires. Okay, so in source place we have some information. That information we have to send to the destination site. So at the time we require some connections. That connection should be done by using wires. Okay, so in code also we have to use in that place only. So whenever we have one gate information should be transferring to the another gate, then only we have to use what wire as a keyword. Okay, so here we have written some standard syntax for writing the what net data type. Okay, net underscore kind, that is a we are initializing net declaration. Okay, that is not a standard word. So after that, always net should be declared by using wire. So you can write a predefined word as wire. Okay, so all keywords must be lowercase. Remember it. Wire. So which variable we have given? Okay, so we'll give one example. So we'll take one example. So first, we are designing NAND gate. So NAND gate should be designed by using one AND gate and one NOT gate. Okay, so here what we will do. So first we will take AND gate. So for AND gate we have two inputs. I will call it as A and B. So output I will call it as Y. Okay, so whatever information should be there at Y, so that information should be given to the input of the NOT gate. Okay, so after that output of NOT gate, we will get it NAND gate output. Okay, so at the time for such designing part, we have to write the code. So at the time in your external lab exam, what he will do, what external examiner will ask, so you have to show the whatever information should be getting at the output of the INT. So at that time you have to write the wire, and also that should be act like a output also. If you don't require the information about in between connections, so at the time you can skip it, no problem. Is it clear? So that connection should be what connected to the what input of the NOT gate. So at the time we require some variables. We have to call by some variables. So at the time a variable should be declared by using what net data types. Okay, so we have written there wire A. That is a if keyword should be wire, then that is a net declare type. Okay, declare net A for the above circuit. A should be acts like a wire. That is a net data type. Wire B comma C. Okay, so that declare two wires B and C are the above circuit. Okay, B and C are acts like a wires. Okay, so wire B is equals to 1 tick mark B of 0. So at that time D should be acts like a wire, but that D should be have some value. So that should be in terms of binary 0 value. Okay, so D have value, that value is also already we have initialized it in the that syntax. Okay, so D should be stored one bit value, that should be 0. That should be in terms of binary. Whenever if you want to write like this, you have to use this format. Next, whenever we are have complex circuit, at the time same variable we will get it twice or thrice. So you will write it as A1, A0, A2, A3, A4. In such pattern, if you are initialized in your circuit diagram, so at the time, how will you write it? By using vector initialization. By using vector initialization. Okay, so at that time, we will use wire, that is signed. So whatever bits should be contained, so those all should be in terms of sign bits. Okay, signed. So 7 down to 0 is nothing but, so that whatever variable we have taken, that what in front of that we have written PW data and PR data. Those are the variables. Those are the variables. Okay, so those variables having wide of what 8 bit. That is 8 bit. Whatever data should be contained on that variable, those all should be in terms of sign. Okay, so that should be a signed way. Data should be present in that net data type. Okay, so whenever we have net declaration, we have to go for this concept. Okay, so whenever we are discussing whenever we are writing the course, so at the time we will write by using quads. Okay, so we'll go to the next concept, that is registers. Okay, so here register is also a type of data. This one is also type of data in Verilog. Okay, so what is register? A register is an abstraction of data storage element. Remember, what is register? Register is a data storage element. By using register, we are storing the data. Okay, so here the keyword for the register data type is REG. So this keyword we have to use whenever we are writing the Verilog code. Okay, so next, a register stores a value from one assignment to the next. Check here. So whatever data should be there previously, that data should be stored in the register. If you assigned any new value to that particular register, so at the time previous value should be what deleted. So whatever value should be stored new, so that value should be stored in that particular register. Okay, so that one only he has written. Registers retain a value until another value placed on them. Up to that, previous value should be stored. Okay, so the default initialization value for a register data type is the unknown value X. Remember it. So whenever we are writing the register as a data type, so if you are not given any value to that code, so at that time by default it will take it as unknown value. It cannot take it 0, it cannot take it 1. Sometimes what he will do, it he will ask this sub question also. Whenever we are writing the any course with the help of register data type, what should be the default value? What default value it will take it if you are not written any inputs? So here you are writing the what indicate program, you are not given what inputs, but that code should be written by using a register data type. So at that time both inputs should be, it will take by default as XX. That is it. Okay, so we'll move to the next. Register can also be declared as signed variables. Register can also be declared as a signed variables. Such a register can be used for signed arithmetic. Okay, so signed arithmetic is nothing but whenever we have negative number is there in your code, if you want to do the multiplication, if you want to do any arithmetic operations, so at that time, so those also we will write it by using register data types. Okay, so what is the standard syntax for writing the register data type? Okay, So we have to use register as a keyword. So first, always the register should be defined with a predefined word as reg. If it is a vector, so then within the square bracket we have to mention what MSB bit. It should be followed by LSB. If it is only scalar, so we have to write it without square bracket. Is nothing but that is the only one bit. If it is having multiple bits, we should write it within the square. Okay, so that should be range. If it is sign bit, we have to mention it. Okay, register one, register up to n number of registers are there, you can write it, no problem. Okay, so this is about register data types. We'll give one or two examples about register. So how register should be written in your very long code. Okay, so we will show it in your PPTs. So these examples. So we will discuss those examples. We will move to the next data type. Okay. So first example I have given here. So register, a reset. So this one should be a, within the code. We will write it in this format. Okay, a register reset. That should be terminated with semicolon. So after that, we have written some comment. That is a comment, single line comment. Declare a variable, a reset that can hold its value. Is it about? So reset is a variable. That reset we are using in your code. Okay, but that should be act like a register. That should be act like a register. By using that reset, we are storing some values. Okay, so after that initial begin reset is equals to 1 tick mark b of 1. So at that time, so reset should be stored 1 bit binary value as 0. Okay, so that comment also I have written initialize reset to 1 to reset the digital file. After that, we are used hash 100. That hash indicates delay. Is nothing but in first expression we have not written hash, so by default that expression should be executed with zero time minutes. Okay, so with the 0 time minutes we will execute reset is equals to 1 tick mark b of 1. So after that, after 100 time minutes, after 100 time minutes, so your second expression should be executed, that is reset 1 tick mark b of 0. So that one only we have written there. After 100 time minutes, a reset is the asserted. Okay, so that should be first example. Okay, so in that example, if you are not given like 190, so by default it will take it as unknown value. Okay, in second example, so register. So whatever variable we are initializing in that example, so that should be assigned. So because of that reason, we have written as a signed. Okay, so that should be 64-bit wide. That variable is m. So m is a 64-bit wide. So whatever number should be contained in that 64-bit, that should be a signed value. Okay, so after that integer I have written, so that is a 32-bit signed value. Okay, so we will move to the next concept. This one is also very important. So already we have written so many examples with the help of vectors. But now we will study what is vector. Okay, so what is scalar and what is vector? Scalar is nothing but it should be only one bit. That should be only one bit. What is vector? Vector is nothing but it should be contains what? More than one bit. All are similar. All are similar. That should be we have called it as similar. What vector? Okay, so vector is nothing but a group of elements. Those all group of elements are similar elements. That should be we have called it as vector. Okay, so in here whenever we are initializing vector, so in Verilog we are using square bracket. Remember that square bracket indicates what vector initialization. Okay, so here we have written first sentence a net or a register. Check it here. A net or register declaration without a range specification is 1 bit wide. Whenever we are declaring net or otherwise register without range. If you are specifying, that is nothing but that is a one bit wide. That is called it as scalar. Is it clear? So next about vectors. Multiple bit net and register data types are declared by specifying range. Nothing but so multiple bits of net and register data types are declared by specifying range. Okay, so net is a data type, register is also data type. It should be contains multiple bit. Multiple bit is nothing but that have some range, MSB and LSB, that should be contains. So then that should be written by using vector initialization. Is it clear? What is scalar and what is vector? Okay, so that syntax also we have written. We have not used any keywords for initializing the vectors. There is no keywords here. Okay, so that square bracket indicates vector initialization. Okay, within the square bracket, first should be a MSB and it should be followed by column. Next should be LSB. Okay, both MSB and LSB are non-negative constant expressions, and it can be any value. It can be any value. There is no range. Any value you can write it. Okay, so LSB expression can be greater value than MSB expression if desired. Check it here. Always a LSB expression can be greater value than MSB expression. Okay, so we have given some examples. Wire A I have written. So that is a net data types. That is a net wire. If you have written, that is a net data type variable. We have called it as A. But is it vector initialization? No. Why? A should be a variable that should be only one bit wide. That is only one bit wide. Then that should be you called it as scalar. Because of that reason, that first example should not be contains square bracket. Then that should be you called it as scalar. Go for second example. Wire 7 down to 0 bus. So is nothing but square bracket we are using. Is nothing but that is a 8 bit wide from 0 to 7. Okay, so that should be called it as, that variable should be called it as bus. How it should be executed? It should be executed first. Bus 7. What is the seventh bit? Bus seventh bit. Bus is a variable. So the seventh bit. What should be the data? Should be contains in that bus 7. Will execute. Next bus 6. Next bus of 5. Bus 4. 3, 2, 1, 0. We will execute in this form. Okay. Next, there are three buses of 32-bit width. Third example. So because of that reason, that should be initialized by using like this. There are three buses. All bus A, bus B, bus C are 32-bit wide. Then we have to initialize in this format. Next, register clock. Clock is a variable. Clock is a variable, but that is only one bit wide. We are not using any square bracket. Then because of that reason, that should be a scalar. That should be a scalar. Okay, so this one is about what vector initialization. Next, we will move to the integer. Okay, so whenever we are writing the any codes, so at that time, so your input should be in terms of integer value. So how that integer value should be given to your hardware. In your code, how we are initializing the integer. So about that, we will study it. Okay, so an integer is a general purpose variable used for manipulating quantities that are not regarded as hardware register. So for manipulating purpose, we are giving integer. Okay, so the size of an integer variable is 32-bit. Remember, the size of an integer variable is 32-bit. Okay, if you have an integer value more than 32-bit, at the time we cannot provide to your code. Only if it is 32-bit wide, then we have to provide to your code. Okay, so register declared as a data type. Register store value as unsigned quantities, whereas integer store value as signed quantities. Remember it. Okay, register is a data type, but that register will store value as the unsigned quantities. But whereas integer store value as signed quantities. Okay, so integers are declared by the keyword integer. So whenever your code should be in your code, if it present integer as a keyword, then we are providing integer value to your. Okay, so then we'll move to the some examples. So we are given the standard syntax so that we are displaying on your PPTs. So within the bracket we have written integer declaration. That is a we are declaring the integer. So that is not a standard. Okay, that should be after that we have given some symbol. There are two columns. After that, it should be followed by equal sign. That is a variable declaration. That sign indicates that should be a variable declaration. Okay, so always integer should be defined with a predefined word as integer. Integer. So that integer word I have written. After that, next we have to write the variable. So just only we have given one example. Integer I. So whatever data should be present on that I variable should be an integer type. That should be 32-bit byte. Okay, so in your PPTs also I have shown one example, integer counter. Counter should be a variable. Counter should be a variable. Remember, counter should be a variable. Whatever data should be contains on that counter, that is integer type. That is integer type. Okay, so counter, which value should be contains in the counter. So after that we have written initial counter is equals to -1 I have written. So at that time, so -1 should be present on counter. So that counter should be as like an integer. Okay. So next we'll move to the time declaration. How time should be declared in your variable code. Okay. So time variable is used for storing and manipulating simulation times quantities. It's nothing but when we need to use the time declaration in your we have some many expressions. There are 3 to 4 expressions are present in your code. 3 to 4 expressions are contains in your code. Or we have to execute 3 to more expressions. 3 to more expressions if you want to execute. For which time we have to execute all the 3 expressions. Okay, first 0 time unit we should execute the first expression. For executing second expression, so how many times we require? We have to specify in your code. For that purpose, we require the time declaration. Okay, for which time we have to execute the those all the expressions. We have to mention it. For that purpose, we require the time declaration. When we require the time declaration, simulation time. Simulation time is nothing but whenever your Verilog code is converted in terms of waveform. Waveform is nothing but your output. For at which time we have to get the next output. For which time we have to apply the next input to the your hardware. For that purpose, we require the time declaration. Okay, so here time is a variable is used for storing and manipulating simulation times quantities in situations where timing checks are required and diagnostic and debugging purpose. Take it here. Okay. Next, a time variables is declared with the keyword time. Remember it. Okay. So the system functions we are used $time. $time is invoked to get the current simulation time. In your code, if you are written $time, so current simulation time, you will get it. Okay. So next after that, the size of time variable is 64 bit. Remember it. The size of time variable is 64 bit. How that declaration should be done in your code? How will write it? So that is a time declaration syntax. So because of that reason, we have written first. Okay. Next variable, that is a variable declaration. So we have given that symbol. Next, always the time declaration should be begin with what? Time is a predefined word. We have given a time. Okay, so we have written combination of red and black pen. So that should be a keyword. That should be a keyword. Okay, always that should be begin with that keyword only. Okay, time. Next list of register variables. Okay, next in example I have shown it. So we have given that example also. Time save underscore simulation underscore time. That is a variable. Time is a keyword. Okay, so that variable should be we have given some time. We have given some time to that particular variable. Okay, for that particular time, so that that variable should be executed. Okay, so whatever input and whatever output should be provided to that variable, that should be executed at that particular time. Okay, so because of that reason, so initial save underscore simulation underscore time is equals to dollar time. So dollar time is nothing but for whatever current simulation time we are taking. So for that current simulation time, so that expression, that variable should be executed. That is nothing. Okay, so this one is about time declaration. Okay, so these all whatever data types we are studying. So these all data types we are using in your course. Okay, so whenever we are writing any course, so at that time we will clear. Okay, so how that should be written. Next we will move to the next real. Okay, so real is also a data type. So whenever we have floating point number as your input, whenever a real number as your input to your any uh, hardware. So whenever we are designing any hardware, for that hardware we are giving input as a real number or floating point number. So at the time, if you are providing input as a real number, so output is also sometimes will get it real. So how that real number should be written in your Verilog. Okay, so here we have mentioned some 3 to 4 points about real numbers. The Verilog HDL supports real number, constant, and variables in addition to integer and time variables. Okay, so whenever we have to give four integer 4 as a input to the your what your hardware. So 4 is the integer value, so directly we will apply it. But 4.12 your for whenever we are designing any hardware, so input is 4.12. We have to apply that input to that particular hardware. So at that time, how 4.12 should be applied, written in your code. So that 4.12 should be in terms of real number. That is a floating point number. That is a floating point number. So because of that reason, we cannot write it by using integer keyword. So at that time, we have to use what real keyword, real as a keyword. So at that time, that what that hardware or that software will understood. So that should be a real number. Okay, so whatever input, whatever output we are getting, that should be a real type. Okay, so because of that reason, so at that time we have to use a real data type. Okay, so next, the real register data types are declared with the keyword real. Remember it. Okay, so we are written by using keyword real. They can be specified in a decimal notation or in scientific notation. Remember that should be we are calling it as a what real number. Real numbers cannot have a range declaration. Real numbers cannot have a range declaration. Why? So that should be have 4.12, 4.36. So this one should be 4 into 10 to the power of minus 3. If any expression should be in this format, then that should be called it as a real number. That don't have any what range declaration. So because of that reason, that you should remember it. Its default value is 0. Remember it. Okay, whenever we are written any real data type, so default value is 0. If you are not provided any input value, so default it will take it as 0 input. Okay, so when a real value is assigned to an integer, the real number is rounded up to the nearest integer. Remember. Okay, so that should be will take the nearest integer value. Okay, how that standard syntax should be written for real numbers. Okay, so we are using keyword as real. So next, a list of variables. Okay, so we have given some example. We have written some example. Real delta, that is a delta is a variable. Delta is a variable. Okay, in that delta we are providing some input. Some input we are providing. So whatever input should be present in that delta variable, that should be in terms of real number. So because of that reason, we have written real. Your name also you can write it, no problem. So that name should be as like a variable. In that variable, so that should be contains a real number. So because of that reason, we have written. Okay, real delta, it should be followed by semicolon. Whatever we have written in front of that, that should be a comment line. Next, initial begin. Delta is equals to 4 e to the power of 10. We have written. Check it here. What data should be contained in the delta variable? 4 e to the power of 10. It should be contained. That should be expression. Okay, so at the time, so that the scientific notations are there, then we have to use real numbers, real data types. Okay, delta is equals to 2.13. Check it here. 2.13 should be our input. 2.13 should be we are applying to the your code. So how we are applying? By using real data type. Okay, so end. So next initial I. So initial I is equals to delta. So I is an integer. We have taken I is an integer. So whatever data should be getting at the delta variable, that should be assigned to the I. Is nothing but that will take it as an integer value. What whenever if how your output should be, your output should be in terms of real number, but that should be given to the integer. That should be given to the integer. How we are getting the output? How we are getting the next nearest rounded value of 2.13. Rounded value of 2.13 is 2. So at the time your output we will get it as 2. We cannot get it as a 2.13. If you require 2.13, directly what you can give delta only. Delta should be your output if you are written, so we will get 2.13. Okay, so this one is about real data type. Okay. Next, we have another one or two data types there. So we'll discuss. Any doubts regarding these data types? Any doubts? So there is no doubt. So or otherwise, if already I posted the book that is with Panatica. So after that book, you can read it. Any doubts if you are getting about these concepts? Okay, so at the time you can ask to me. So next we have given here. These are the for some real numbers. In your PPT we are showing. So those should be applying for your code. You are applying for in your code. So then those we are calling it as a what real numbers. 1.2, 0.1, 2394 point something, 1.2 e to the power of 12. These are the real numbers. But below that I have written 0.12. That is an invalid real number, right? Before decimal point, we have to give some digits. If written some digit, then that should be a what valid real number. Okay, 0.12 we have written, that is invalid real number. Okay, so we have written the following are invalid real number in the Verilog HDL because they don't have a digital digit to the left of the decimal point. So because of that reason, that should be a what invalid real number. Okay. So next, we'll move to the array. Okay, so we'll move to the array. So here we discuss about the array. So, array is nothing but it is also contains a group of elements. Okay, but if it is contains a similar types, we will call it as what vector. If it is similar type, we will call it as a vector. Okay, but here so array should be what group of elements that should be not be a similar types. That should not be similar types. Okay, so that should be we are calling it as array. When we have to use the array declaration in your code. Okay, so that array should be divided into two types. One is one-dimensional array and another one is multi-dimensional array. Okay, so one-dimensional array and multi-dimensional array. A multi-dimensional array of a net or a variable can be declared using an array declaration. An element of an array can be scalar value or vector value. So that array should be declared by using below syntax. I have written there array underscore name. Next, you can write the subscript. Okay. For multiple dimensional arrays, indexes need to be provided by each dimension. Whenever we have a multi-dimensional array, one-dimensional array is nothing but it should be contained only one element. So that should be we are call it as one-dimensional array. What is multi-dimensional array? It should be contains a group of elements. it should be contains group of elements. That should be we have called it as what multidimensional array. In multidimensional array, we have to write the what indexes. Okay, so whenever we have provided the indexes to the dimensions, then that should be called as what multidimensional arrays. So we will see one or two examples about multidimensional arrays. So we have written those examples here. Okay, so this one is like what vector initialization. So that should be only we have called it as an array. Okay, so integer count 0 to 7 I have written. So count is a variable. So what? So that should be a 8-bit byte. Next register bool 31 down to 0 I have written. That is array. That is array. That should be a register data type. So that is a register data type. That should be 32 bit. Okay. So whatever we have written, this all should be a what array type. Okay. Next we will move to the parameters. Okay. So when we need to write the parameter in your code, parameter is also data type. Okay. So Verilog parameters do not belong to either the register or the net group. Remember, parameter should not be a register group and net group. Okay, parameters are not variables; they are constant. Remember, whenever we have any constant numbers, if Planck's constant is there, those are all the fixed numbers. Those are all the fixed numbers. Okay, if you are applying fixed number to your code, so at that time we have to use what parameter declaration. Okay, whenever we are declaring constant numbers, so at that time only we have to use the parameter declaration. How parameter should be declared? So we have that standard syntax. We have to follow it. So we have to write that parameter should be written by using the what parameter as a keyword. We have to use the parameter and whatever variable we are using for that variable we have to apply. Okay, so in example I have shown parameter. Parameter is nothing but that is a constant. Constant number should be provided to that particular variable. Okay, parameter we have used constant number. So port underscore ID. Port underscore ID is a variable. For that port underscore ID, you have stored the value of 5. 5 is a fixed number. That number should be stored in port underscore ID. So because of that reason, we have used parameter. If fixed numbers are there, then that should be written by using parameter key. Okay. Next, what is string? String is a sequence of characters written in double quotes. Okay, a string may be split across lines. Examples. So we have written hello very loud. Within the double quote I have written that is a valid string. Internal error, double quote, reached here. That should be in double quote. Okay, sequence of characters should be contained within double quotes. That should be your called as strings. Okay, so how string should be written? Here we have given some examples. Okay, so next, so this system task and display information. So we will discuss it in the next class.